Okay, okay, guys, welcome to lesson 2 on hydrocarbons, unit 2, National 5 chemistry. So, last time we did alkanes, you should have all filled in your OneNote answers to all the tasks. I'll get around to marking them when I can. So, now we're on lesson 2, which is alkenes this time. So, you need to know the difference between an alkane and an alkene. That's one of the learning intentions for today. And you should be able to recognise an alkene from its structural formula and how that's different from an alkane. You should be able to draw the structure of all 7 of the alkenes. Remember, there's no methene with 1 carbon. The first alkene is ethene, and you should be able to state the general formula for an alkene as well. So what we have here is alkanes and alkenes. Remember, alkanes are saturated. So if you think of that of like a sponge, a saturated sponge, there's no way any more hydrogens can get in here. They're totally saturated. If we compare that to alkenes, alkenes are unsaturated. So there is plenty space for hydrogens to go in there, 2 spaces in fact, usually on each one. So they are unsaturated. Anything that has a double bond in it is classed as unsaturated. And the first 2 members of the alkene family are ethene and propene. That's just what I've covered previously. Ethene and propene. C2H4 and C3H6. So you should be spotting a trend between the number of carbons and the number of hydrogens already here. So in your OneNote you will have a table similar to this. I just need you to stop this video here and then go and start to complete this table in your OneNote. Okay, you all should have completed that table above in your OneNote. So can you work out the general formula for alkenes? Pause this video now and then have a go what you think it is. So the general formula is CnH2n. So all you have to do is take the number of carbons that you have. Say you have 100. H would be 200. If H was 60, then carbon would be 30. You just double the amount of carbons you have to get your hydrogens. Nice and easy. Right, back to fractional distillation for a bit. Let's talk about something called cracking. Cracking is when we take large alkanes, so saturated compounds, and we break them down using an aluminium oxide catalyst, and we break that into a small alkane, and we also get a smaller alkene out of that. And all the carbons and all the hydrogens must add up to the same number. So let's start with a large alkane. Let's start with decane. C10H22. Double it and add 2. Let's say we wanted to break that down to a small alkane like butane. So C4H10. That's butane. So what are we left with? We've got 4 carbons here, but we have 10 on the left, therefore we have 6 remaining. So that would be C6. We have 10 hydrogens here, 22 here, so therefore we have 12 remaining. C6H12, you only have to double that number to get to that, so that's hexene. So we have an alkane plus an alkene. Hope that makes sense. So here's a picture of fractional distillation. You should remember this from S3. They're all done in order. You'll be able to see that C1 to C4 gases are all up the top, and then we go down to the C5 to C9, they're all liquids, and then it goes up to C10, C16, C20, C50, and then C70. And then right at the bottom we have the residue. That's usually tar that goes on the road, bitumen. That's got the highest melting point, highest boiling point, so that always sinks to the bottom. So various fractions. Petrol, remember, is octane, and they are ranked in terms of their boiling point and melting point. Just remember a few different uses for each of them. Jet fuels here, diesel, petrol, jet fuel, diesel in that order. Waxes, so that they're more solid. Hair wax and things all there, and then bitumen for the road all the way down the bottom. So that's just going over cracking again, and then a little experiment that we could have done in the lab, which we no longer can. So let's look at 1, 2, 3, 4, 5, 6, 7, 8. So this is octane here. Octane's present in petrol, and we're going to crack octane. I'm going to crack it right down the middle. That's going to leave us with C4 and C4 on each side. Remember, it's always an alkane and an alkene we make. So we removed one of those hydrogens to there. So that leaves us with butane and butene after cracking. So all carbon and hydrogen atoms must be present in the new molecules. So that example from the previous page, we started with octane, which is CaH18. So remember, it's CnH2n plus 2. We break that down to butane and butene, our alkane and our alkene. C4 plus C4 gives us C8. 10 plus 8 gives us 18 hydrogens. So everything's balanced on each side. And just remember, cracking always produces an alkane and an alkene. Cracking is really important if we want to make polymers. Remember in our plastics topic, a popular monomer was ethene, and we can make ethene from 1, 2, 3, 4, 5, 6. So we're starting with hexane here. We're cracking it. That's going to make us ethene from the left hand side, and it's going to make us butane from the right hand side. Butane here. Again, it's an alkene plus an alkane. And ethene, remember, we can join lots of those together to make polyethene, and here's polythene bags here, and other plastics that are used in our plastic bottles. Right, let's move on to addition reactions now. So alkenes can undergo addition reactions. Alkanes cannot. So we're just going to look at what an addition reaction is, look at what the test for unsaturation is, and name some products. So as a recap, alkanes are saturated, alkenes are unsaturated. So there's room to add things in here. And that's the clue. We can add things in during an addition reaction. And that's what we're going to be doing here. That's why we cannot add things into an alkane. So it needs to be on alkenes only. So there's no spaces in an alkane, but there definitely is spaces on an alkene. So let's start with this one on the left here, which is butene. We're just going to add hydrogen gas to it, and you can see they just fill up the two missing gaps here and here. So butene plus hydrogen, and we use a nickel catalyst for this just to speed it up a little, can make us butane. Just ignore that. Butene makes butane. Adding hydrogen, so this is just our simple addition reaction. And this is also known as hydrogenation. So it's an addition reaction or a hydrogenation reaction. Need to know the name of both of those. So let's start off with butene again. This time we're adding diatomic bromine, and we are making dibromobutene. butane. Remember, di means two, so that part means two. Bromo is because you've added bromine in, and it's butane because there is 4 carbons there. Dibromobutane. You can also add chlorine. Let's say we added chlorine to this. Cl2. 1, 2, 3, 4. Let's all pause this video just now and see if you can name this, and then we'll come back and try and name it. Right, have you all had a go at naming this? It's similar to the one above, but this one would be dichlorobutane. Last time it was dibromobutane, this one is dichlorobutane. Okay, the test for unsaturation. Let's say we had hexane and hexene. I gave you these two. They're both colourless liquids, and I told you to go away and do a test and tell me which one was which one is hexane and which one is hexene. So what you would get is some bromine, water, Br2, which is brown in colour, and you would add it to both of these solutions. In the hexane is totally saturated, so there's no space for the bromines to be attached on. 1, 2, 3, 4, 5, 6. That's all totally filled up, so there's no way. So you'd just be left with the bromine sitting in that solution, which would make it stay brown. However, if you added bromine water to hexene, 3, 4, 5, 6, the 2 bromines would add on where the double bond was, and all the rest of these would be hydrogens, and that would no longer be brown because the bromine is added into this solution, and that would be colourless. So the test for unsaturation is an alkene will decolorise. So it's changed it from brown to colourless. So an alkene decolorises bromine solution from brown to colourless. That's a test for unsaturation. Right, last addition reaction, we can take an alkene, and again we have butene here. We can add water to it. Remember, water exists as OH minus and H plus ions, and effectively the hydrogen can be added on here and the OH can be added on here. Another addition reaction. This time we're adding in water. Start with butene, and this is called butanol. So it's but because there's 4 carbons, and anything that has an OH in it is an alcohol, and we've just made butanol. So let's say we started with hexene and I added water to it. What would be the name of the alcohol that was produced? Pause this video and have a go what you think the name of it might be. Okay, did you all have a go? Hexene plus water, butene plus water gives butanol, so hexene plus water must give hexanol. And the addition of water is also known as a hydration reaction. You should all know when you drink water, you're rehydrating or you're hydrating yourself, so that's a hydration reaction. Adding water into something is hydration, and you can make the alcohol. And this OH group, this OH group here is called a hydroxyl group. It's got an hydrogen and an oxygen. Hydroxyl group is another name for an OH group. Okay, so if you all now go to your OneNote for lesson 2 on alkenes, you'll have the learning intention success criteria there. You have the lesson in here, and you also have this video in here that you're watching. You have a little starter task, you have your alkene table, and you have some task questions there to try and work out what the answers to those will be. Remember, and write them in the text box. And then again at the bottom you've got consolidation problem solving questions. Right, have a go at them and then I'll mark them. Good luck.